Esteemed PhD candidate, the Committee of Deans of this university is represented here by us in this web-based ceremony. After reading your PhD thesis and the accompanying propositions, and after propositions, we are ready to hear you to defend it. Please take your seat. This is the first web-based PhD ceremony of the University of Groningen in this very special era of coronavirus pandemics. So in fact, you are a little bit part of an experiment. But I learned from your thesis that you are very much used to experiments. Having said that, and after seeing that there are no questions from the audience here today, I give the floor to the first opponent, Professor Bank, a professor in regenerative medicine of the University of Groningen, and member of the reading committee of the thesis. I thank him for his work, and Professor Bank, please go ahead.
Okay, thank you. So, dear candidate, first of all, I want to congratulate you with this very nice thesis, and also I want to congratulate your supervisors. And as the rector already said, you're writing history. It's a special day for you, but also for the university, because this is the very first web-based defense. So you have looked, let's say, to all kinds of diseases from the liver. You've investigated the effect of extracellular vesicles on the diseased liver. So you mentioned in your thesis that when you inject stem cells into the bloodstream, the cells will migrate to the diseased liver. And there the stem cells are able to attenuate fibrosis. So my question is now, when in vivo, do the cells attenuate fibrosis by extracellular vesicles or by the secretion of paracrine factors?
Please go ahead.
Hooggeleerd opponent, thanks for your kind words and question. Unfortunately, I did not hear the question really well. May I ask to repeat it once more?
Yeah, okay. I will repeat it again.
Thank you.
In your thesis, you mentioned that when you inject stem cells, the stem cells are able to attenuate fibrosis because the stem cells migrate to the diseased liver. And my question is, do the stem cells attenuate fibrosis by extracellular vesicles or by the secretion of paracrine factors?
We assume that based on the investigation we had, we assume that these are the effects of extracellular vesicles to suppress fibrosis, as we showed it directly on liver fibroblast in chapter 2, and also in a vivo model of 4 weeks CCL4. But at the same time, I cannot say paracrine, let's say, soluble factors of the stem cell condition medium do not have any effect, as there are other studies which showed that soluble factors have some effect. But in our hand, only extracellular vesicles, at least in vitro, were the ones that could suppress activation of liver fibroblast.
Okay, as you said, you have done it in vitro experiments, so you cultured the cells themselves. But these culture conditions are quite different from the in vivo situation. You culture them on plastic, which is a very stiff substrate, and also you culture them on 20% oxygen level, which is very high because in the in vivo situation, it is about 5%. So I wonder, the extracellular vesicles that are produced in culture, are that the same extracellular vesicles that are produced in vivo by the stem cells?
In this regard, you are absolutely true. We have often differences in between in vitro and in vivo condition, and myself also assume there must be differences between these two situations that also influences the quality, production, and other factors regarding extracellular vesicles. And that is also another reason that we cannot be absolutely sure that these are only extracellular vesicles that do the job, the antifibrotic job in the conditioned medium of adipose-derived stem cells. But yeah, as you remarked, in line, I think so. I think so that I also think that this in vitro and in vivo difference could be a matter of discussion at the end.
Okay, then I think there's time for another question. There is. Okay, so let us go to chapter 3 to figure 2 on page 51. Yeah, you have the page. So on the first row, you see collagen staining. So take a look to the control of the portal myofibroblasts. There is a lot of collagen staining. And the cells that are treated with the extracellular vesicles do not show collagen at all. It's completely zero. There's no staining. So if you look to the figure 1 page earlier, so that's page 50, then if you look to the messenger RNA levels of collagen of the same cells, treated with or without the extracellular vesicles, you see that the decrease in messenger RNA is about 50%. So there is still a lot of messenger RNA of collagen present. Whereas in the protein staining, you don't see collagen at all. There is no staining at all. How do you explain that? Because that is a strange phenomenon.
In this case, I have to come back to the fact that often happens that we see differences between gene expression and the protein level. And of course, it could have different reasons. For example, could be effect of like genetic effects, such as effect of microRNAs in between that we see it in gene expression level one thing, and in a protein level we have less amount of collagen.
Okay, yeah. So there's not really a very good explanation for it. There can be several factors that are responsible for it. Well, it's interesting because in my own investigations, I don't see collagen staining in fibroblasts, whereas I do see staining in myofibroblasts. And again, the level of messenger RNA is only 3-fold different. So this is a very nice topic for further study. So I hope we can continue with this research. I now give the word back to the rector.
Thank you very much, Professor Bank. I have first a question to Professor Faber to shut off the microphone. While you hear background information. Thanks a lot. I would now like to proceed with another opponent, and that is Dr. Bansal, Associate Professor in Targeted Therapies of the University of Twente. And I'm very happy that you can make it to be at this ceremony, Dr. Bansal. Please go ahead. There you are. Your microphone, your microphone on.
Thank you, Chairman. Dear candidate, dear Daniel, first of all, I would also like to congratulate and your promoters for this beautiful work that's compiled in your thesis. I read your thesis with really great interest and completely agree with your telling that the thesis is not a one-man show. Although we had a lot of discussion during the liver conferences, I have several questions which came to my mind during reading your thesis. So I will start with my first question. So in your chapters, all 3 chapters, basically 3 and 4 and 5, you showed that the stem cells or adipose-derived stem cells, cellular vesicles, were effective. However, you didn't perform any studies with other extracellular vesicles or as a control extracellular vesicles from hepatocytes or from other cell types. So how specific these results are?
Zeer geleerd opponent, thanks for your positive feedback. In this regard, I have to say that we have not tested effect of any other extracellular vesicles, I mean from any other cells, rather than adipose-derived stem cells in vivo and in vitro in the case of liver and liver cells. But based on other studies, I assume that not every cell type has extracellular vesicles from every cell type could have the same therapeutic effects. And these therapeutic effects are coming from the special condition and special character of stem cells. In our case, adipose-derived stem cells.
Okay, with that, it leads me to the second question, that you saw that the effects of your extracellular vesicles were more pronounced in CCL4 model in the chronic, where you have a 4-week CCL4 treatment, while you didn't see, or you had a modest inhibition in the acute CCL4 model and also in the NAFLD model. So these effects which you observe, are these model specific? So why do you think it was more effective during your chronic CCL4 treatment, while not in the acute CCL4 or in the NAFLD model?
I assume that as you remarked, these differences are pretty much model dependent. And a good example you remark is about the difference of extracellular vesicle effect in a chronic model of fibrosis and the acute model. Especially in this model, I think the number of interventions with extracellular vesicles that in a chronic model is 4 times, and in an acute model is only 1 time. It could be the reason. And also, as you know, in an acute model, we had a big shot of CCL4, and afterwards, as I said, only one time infusion of EVs. But in a model of in a chronic model, the long span of experiment led us to infuse exosomes, EVs in more times. And that also could be the other reason for this difference. And also times of sacrifice in these models that could be the case that makes differences between model to model. And again, the time of intervention, like whether we infuse extracellular vesicles prophylactically or therapeutically, could make difference. And I should come back to the first sentence you remarked, that these are really, these therapeutic effects are really model dependent.
Thank you. And the final question, if I may ask, is now you have studied different models. You have studied from chronic fibrosis, but also early fibrogenesis, and you have also studied the NAFLD. So you have a whole spectrum of diseases. So with this knowledge, where do you see this extracellular vesicle as a therapy? So do you think it will be more effective at the inflammatory stage or at the late fibrosis stage? And then in which disease, or is it irrespective of etiology that you can treat patients? So how do you say it? How do you see it in application? So how do you think it can be a therapeutic approach?
In this case, I think the earliest we can intervene with extracellular vesicles in a case of liver disease, it doesn't matter the acute model or the chronic model or NAFLD model, acute model of fibrosis, or a chronic model such as fibrosis model or NAFLD, in our case, steatosis. The earlier we can intervene with extracellular vesicles is the better to get more therapeutic effects.
Okay, thank you. I give the phone back to the chairman.
Okay, so you are happy with the discussion. So then we would like to go on with the next opponent, and that is Professor Olinga from the Faculty of Science and Engineering here of the University of Groningen. And there he is. Please.
Thank you very much, Mr. Rector. Esteemed candidate, dear candidate, I first like to congratulate you with your very nice thesis. And I also like to extend my congratulations to your team of supervisors. Strange times, and I chapeau for you that you are sitting there on your own. But I'm not asking you anything about fibrosis now. I'm going back to my old love, which is paracetamol and drug toxicity. So that's why I want to talk to you about chapter 4. And one thing I want to ask you first is that you did experiments in vivo with APAP and used 300 milligrams per kilogram of APAP in these mice. This is a quite lethal, almost lethal dose. And did one of the animals die during your experiments when you used paracetamol in your case?
Hooggeleerd opponent, I appreciate your positive review regarding my thesis. In this case, I have to remark that we had no dropout. None of the animals died during the experiment. None of the mouse died during the experiment.
Okay. And then I want to go to chapter 4 and then page 72 and then graph, what is it, figure 3A. And then you see nicely that you did both the prophylactic and the therapeutic intervention, and they have a clear effect on ALT and AST in both cases. And I would have predicted that as you just also said, that how earlier you start, so prophylactic, would have a bigger effect than, for instance, when you do it later. In this case, after 1 hour after the giving APAP itself. So I couldn't explain also what you just said. How is that possible that in this case it looks like that the prophylactic has the same effect on ALT and AST as the therapeutic intervention? Can you explain why there is where there's no difference in this case between prophylactic and therapeutic intervention?
It is actually a surprise that in this case the effect of therapeutic effect of exosomes, EVs, is as strong as prophylactic effect of them in a APAP model. But again, coming back to the fact that, to the point that these effects of really model dependent, and at the same side by side of that, we did not observe the same effect in a model of acute model of CCL4. Then in CCL4, we had a lot of a way better effect in prophylactic time rather than the therapeutic time of intervention. I can say I do not have clear explanation for this phenomenon that in APAP model we have more or less the same therapeutic and prophylactic effect, except this is the character of the model that we are not aware of details at this moment.
Talking about details, why is APAP toxic to the liver? After usually what happens after injection of APAP to the mouse or mammalian organism, the metabolites of APAP are toxic to the liver, and mainly it's because like a clear and fast drop down of reduced glutathione that causes increased amount of ROS in the liver, and therefore leakage of ATP from mitochondria and ends up in necrosis. That is how APAP is toxic to the liver. So the toxic metabolite, which is toxic, is produced by cytochrome P450. It's NAPQE. Do you think that your extravascular vesicles may have an effect on the cytochrome P450 itself, and in that way inhibiting the metabolism of paracetamol?
I assume that is possible, but we haven't tested in this chapter whether they have an effect on cytochrome P450, but I do not see it impossible that this effect exists.
And when you look at these EVs, how are they harmoniously distributed over the liver itself? Or do you think they clot somewhere? Because you have these zones within the liver, from zone 1 to zone 3. Do you think that they will taken up in every zone of the liver?
Based on studies of, we haven't tested that ourselves, but based on studies of others, they spread all around the liver. But yeah.
Because paracetamol itself has mostly zone 3 toxicity, and it could be then that maybe there's more EV going into the zone 3 hepatocytes. Can I have more questions?
Yeah, a brief one, please. Yeah.
So do you think that when you did this in the paracetamol, that the main thing in the end would be that these microRNA are doing the trick of the effect of on the model paracetamol in the EV?
We observed actually, like based on microRNA, on some in silico analysis we did on isolated microRNAs from EVs, we found that a couple of these microRNAs are involved in regulation of cell death. And we assume that there could be a link that these microRNAs involved in cell death regulation are involved in suppression of cell damage in APOP model.
Okay, thank you very much for your answers, and I give the word back to the rector. Thank you very much.
Thank you very much for this vivid discussion here. And then I would like to give now the floor to Professor Lisman from the Department of Experimental Surgery of the UMCG here in Groningen. Please go ahead, Professor Lisman. Yes.
Thank you. Good morning, dear candidates. Also, I would like to congratulate you with your thesis, which I read with a lot of interest. Also, would like to congratulate your team of supervisors. And I would also like to congratulate you by being so brave, because you're the first one to defend online. I think so far you're doing a great job. So congratulations with that as well. I would like to continue discussion on chapter 4. And if I look at your abstract in chapter 4, you conclude that extracellular vesicles hold promise as a novel off-the-shelf therapy to treat patients with acute liver failure. And so, as you discussed both in this chapter, but also in the beginning, in the introduction of your thesis, acute liver injury is about injury, but also about repair, and about failure to repair, or about balance between injury and repair. And so what you're showing in this chapter is clear effects of these extracellular vesicles on injury, but you haven't studied repair at all. So, and my first question is, why did you choose to only study injury and not look at repair as well?
Please go ahead.
Hooggeleerd opponent, thanks for your positive words and opinion. I guess I'm not sure if I understood your question really clearly. But what we studied in chapter 4 is therapeutic effect and prophylactic and therapeutic effects of extracellular vesicles on acute models of APOP and CCL4 liver toxicity. To my opinion, extracellular vesicles had repair, both prophylactic and repair effect on hepatocytes, at least in liver. In this case, I do not understand it clearly. What your question in between?
So let me rephrase. So a mouse or a human with acute liver failure is characterized by massive necrosis of the liver, right? And so the injury is causing acute symptoms, but whether the patient survives spontaneously or dies or requires a liver transplant is dependent on whether this necrosis is resolved. So successful treatment of acute liver failure are much more about repair of the necrotic lesion than of avoidance of this injury, because once this patient gets into the hospital, the damage has already been done. So what I would have expected in this chapter is also experiment on repair, so on regeneration of that liver, dividing cells, how much necrosis is there after a few days after injury. So I was just wondering, why did you choose to only look at this early injury step and not look at repair?
Yeah, in this case, as you remarked, we try to look at the early phase of damage in both models, and one of the clear reasons is that generating models that represent really heavy damage in a liver in mouse is more complex. As I got in the first question of the first opponent, we could get a lot of drops out in deaths of animals during the experiment. And on the other hand, we considered this the first time a trial of EVs in liver injury models as a beginning in this field. But I assume that in further times, like in future experiments, because now on we could see that we see the effect of EVs in early phase of damage. In future, we would spend time on generating like models of mouse with heavier damage, and then checking the effect of EVs on these models with heavier hepatocyte damage. And these two models we generated were like the start of the research in this area. And that I can consider it as the main reason that we began whole the process with really minimum damage to the liver, to see whether EVs have any effect prophylactically and therapeutically on this minor damaged liver in mouse model.
Okay, so let's move on to what's actually going on in these therapeutic effects that you see. So you stressed that the microRNAs might be very important. I think you shouldn't exclude the fact that there's also messenger RNAs that could do the trick, or proteins within these extracellular vesicles that do the trick. And I was wondering whether you could elaborate a little bit on, so you're using human cells or human extracellular vesicles derived from human cells in mice. So how similar or how different are potential RNAs or proteins in human cells compared to mice? So how certain are you that the effects you see are not species dependent?
You're absolutely right on this point, that during all the thesis, including this chapter 4, we tested the human adipose-derived stem cells, the vesicles from human adipose-derived stem cells on models of, on in vitro models of rat cells, or in vivo models of mouse. The point is, coming back to the microRNA cargo of extracellular vesicles, which not only us but many research teams believe that are the one of the main factors in therapeutic effect of these EVs. I have to remark that most of the microRNAs are quite conserved among different vertebrates. And based on this, we can rely on intervening mouse models with human-based extracellular vesicles.
Okay. I can see on my kitchen clock that it's time, so I give the word back to the rector.
Very accurate. Thank you very much for this opposition, Professor Lisman. I would like to give the floor to Professor Moshagen from the Department of Experimental Hepatology and Gastroenterology. And there he is. Please go ahead, Professor Moshagen.
Thank you, Mr. Rector. Dear candidates, of course, first of all, my congratulations to you with completing your thesis and also to your team of supervisors. It's a very special occasion. It's the first time that we are having a PhD defense by video. For you, it's a unique position. It's also the first time that someone was able to make me wear a tie in my own house, which I usually do not do, but so you're unique in several respects. Some of the questions I had for you were already addressed a bit by Dr. Banzal and Professor Orlinga, but nevertheless, I would like to discuss with you a few of those topics, maybe go into a slightly different direction. The first one is that in my group, we've been doing some work on extracellular vesicles as well, and also from extracellular vesicles, EVs I will call them, which were from hepatocytes treated with fatty acids, so fat-laden cells. And these EVs behave in a different way than EVs from cells that are not treated with fat. So my first question is, your human adipose-derived stem cell vesicles are from material obtained after liposuction. So they are obtained from fat people, or at least obese people, or overweight people, or whatever. You state in your materials and methods that the donors had a BMI of less than 30, but nevertheless, as a kind of speculative question to start with, would you expect that EVs from your donor material would behave in a different way if you use EVs from donors with a BMI that is lower, as opposed to those that with a BMI that are higher? So you limit yourself to a BMI below 30, but what would happen if you have EVs from a BMI of 40 versus 20? Would you expect differences?
Hooggeleerd opponent, I appreciate your positive words regarding my thesis and promotion. As you remarked, I also assume differences, or at least I can question myself in this regard, that whether we have, whether these quality of EVs are donor dependent or not, that I can say yes, as I observed it previously in my research work. These, as an example, I can say EVs from younger donors have, let's say, different therapeutic effect than EVs from older donors.
But I'm not talking about young versus old, but let's say the dependency on BMI.
I understand. That was an example to say that quality of EVs is donor dependent, and in line, I assume that, or I can expect that the BMI of the donor also influences the quality of EVs or exosomes that you are busy with in your research team. But we haven't tested that, but I assume, yes, there could be effect on the quality of EVs.
Okay, then let me move on along the same line. So basically what you do is that you give your mice, which are subjected to a model of liver failure, the extracellular vesicles from human adipose-derived stem cells. I assume that the rats or the mice themselves also have fat tissue. So they also have adipose-derived stem cells within the mice and the rats that you treat. So why is that not enough for the rat or mice to recover from the insult? So why do they need additional material from fat tissue, let's say, outside the rat or mouse? And would it help if the rats or mice would have more fat? So more fat, more adipose-derived stem cells, so more vesicles released from adipose-derived stem cells within mice or rats. So would lean rats be more vulnerable to your insults, you CCl4 and acetaminophen, than let's say more chubby mice or rats?
It is always my own question to that, whether more obese human or rat, let's say mammalians, are more secure against acute and chronic liver disease or not. But so far I have no answer for it. But just an assumption I can have in response to your question is simply the number of EVs circulating, like let's say adipose-derived stem cell EVs circulating in a body of mouse is not enough to suppress acute and chronic liver disease. And in every shot of exosome, a shot of EVs that we give to mouse, we injected over 200 million EVs. Or in the case of acute model, model of liver damage, we injected 400 million of EVs. I assume this abundance of EVs are also important in therapeutic effect of these particles, that normally in a body of mouse, we do not have this many EVs circulating in the system. Okay. Do I have time for a final question?
No, I would like to stop and give the floor to the final opponent, if you don't mind.
Thank you. I give the word back to the rector.
Okay, thank you very much. Because I really want to give the floor now to Professor Burgers from the Department of Pathology and Medical Biology, and especially from the regenerative medicine. Please go ahead.
Thank you.
We have to change.
Esteemed candidate, I would also like to add my congratulations to you and your supervisory team for this very interesting piece of work, which I read with great interest. I'd like to explore further the models that you've used in Chapter 3 and start with the human precision cut lung slices. I'm intrigued that you propose this as showing early onset of fibrosis, and wonder, what do you think is inducing the fibrosis in this model?
Hochgeller opponent, thanks for your positive review. Although these precision cut liver slices are taken from excess material surgery for donation, liver donation, then I can say they are from a really healthy liver. But still, during the process of preparing them, during the process of cutting, we can have hepatocyte damage, and therefore we have inflammation and activated repair mechanisms, and therefore a sort of early onset of fibrosis.
So why would you classify that as fibrosis and not normal wound healing?
It is, to me, this is really the border of wound healing and fibrosis, and that is the reason we call it early onset of fibrosis, not an absolutely clear fibrotic model.
So then you're implying that your EV therapeutic approach is inhibiting a natural healing response. So I wonder, do you think that this is then potentially a problem with this therapeutic approach?
I really hope that these EVs are not against the wound healing process. Otherwise, it could be a big problem for the therapeutic effect of them. There would be more damaging them. But at the same time, I consider the stage of wound healing in precision cut liver slices not really wound healing, but is a little moved toward generation of fibrotic tissue. And I trust the model that it has been tested before for markers of fibrosis, that we have expression of markers like PAI1 and HSP47, which are early markers of fibrosis, and all are overexpressed in this precision cut liver slices.
So is all fibrosis bad?
I didn't hear. Sorry.
Would you say all fibrosis? So you're saying that you're detecting markers of fibrosis in this model. Would you say all fibrosis is bad?
To my opinion, when wound healing proceeds to fibrosis, it is bad.
But when does wound healing become fibrosis?
At least in the case of liver, when the balance between the secretion of ECM and degradation of them goes towards accumulation of extra ECM, I consider it fibrosis.
Okay. So you've shown that your EV treatment has a protective effect in many models. Do you think this is likely to be specific for your liver fibrosis that you're studying, or is this possibly a more generic feature of EVs that could be applied in many diseases?
I assume that not only my own assumption based on data we got, but also relying on publication from other research teams, these EVs are not only anti-fibrotic, but they have therapeutic effect on many other diseases, such as inflammation in other organs, including lung, kidneys, brain, and also they have a strong immunomodulatory effect in the different organisms so far as they have been used in autoimmune diseases, for example, successfully to the date.
Microphone, please. Microphone on, please. We have.
Sorry, it keeps turning off.
Yeah.
When you administer your EVs systemically via the tail in your in vivo models, how can you then say that this is a direct effect of the EVs and not a result of that immunomodulatory characteristic you just described?
I assume that remains a question forever until we test the effect of these EVs on the immune system as well. Otherwise, we cannot judge it really well. Something we observed was a clear effect of these EVs in different models, both on hepatocytes and myofibroblasts of liver. But at the side, I assume that effect of these EVs on immune system, as I said, they are immunomodulator particles, also exist. And that would be an extension part of this research for future to test effect of EVs on the immune system.
Okay, so you've shown very nicely that the microRNAs, you believe, are one of the active agents within your EVs. What's the relationship between the amount of EVs and the amount of microRNAs that are then required for the therapeutic effects?
Sorry, I could not hear your last question really well.
I'm asking you about, you've shown you think it's microRNAs within your EVs that are part of the active agents. And I was wondering about how much microRNA is needed to then have this therapeutic effect.
To answer, I have no clear answer for this question, as I see a lot of contradictory results on publications of others, and I haven't tested it myself yet. I cannot say the more microRNA, the better therapeutic effect, or like less, or something really clear in this way. But if I come back to a level of how many EVs we need to have to observe certain therapeutic effect, I can remark that effects of EVs are really dose dependent. And one of the future recommendation to work with EVs, especially in clinics, is to find the proper, or to adjust the proper dose of EVs to suppress a certain disease.
can finish your sentence, or are you finished?
It's finished.
Okay, that's very well in time. So you are satisfied as well?
Yes, thank you. I hand the word back to the rector. Thank you for the discussion.
Okay, thank you very much. Then the Committee of Deans will withdraw for some time to consider its decision. Ik loop niet. Esteemed PhD candidate, the Committee of Deans of this university, as represented here by us here in this web-based meeting ceremony, after reading your PhD thesis and the accompanying propositions, and after reading your defense, that was quite well, has decided to award you the desired PhD degree at the University of Groningen. Your promoter is already there. Professor Faber is authorized to award you this honor in the customary fashion. Please go ahead.
I am happy to accept the task assigned to me by the Rector Magnificus. However, before performing this task, I would like to address a few personal words to you. Dear Daniel, this is a strange time for all of us, but especially for you and me now. Nothing is according to the customary fashion, as the rector just said. Also not this thesis defense. But I'm very happy for you that this online thesis defense was made possible by our university, and you did a great job. I am very proud of you, and on behalf of Professor Harmsen and Professor Kambay, you are both other promoters, I am so happy to congratulate you, because at the end of this speech, I have the honor to award you the PhD title. Your personal life is upside down right now. We thought the timing of your defense was excellent. If everything had gone as normal, then you and your girlfriend Hannah would have become parents in 1 or 2 weeks from now. You also would have gotten the Dutch nationality. And you would be preparing to move to Bochum to start as a postdoc in the laboratory of Professor Kambay. But everything changed about 12 weeks ago. Your son Oscar was born premature at 26 weeks and requires intensive care ever since. You always was a dedicated hard worker in the lab, but now you work 24/7 in the UMCG. You came to my office regularly to give me an update, and it was very clear to me that you were very concerned about Oscar, but also for Hannah. This is a very heavy time to go through as new parents, and we all hope that soon Oscar will get better and that you can bring him home. And then a few weeks ago, the coronavirus invaded the world and also the Netherlands, and public gatherings were forbidden, just like these PhD defenses. We could have chosen to postpone your defense to much later, but you really wanted to proceed with it, so you could turn your full attention to your young family after today. I am really happy that we got the full support of the director of the graduate school, Martin Smit, our faculty dean, Marianne Joels, and our university rector, Siska Weiminga, to try and organize an online web-based PhD defense, especially for you. So this is what happened today. And I also want to thank the rector of today, Professor Kluin, the faculty beadle, Henriette Niebold, and all the opponents to make this online ceremony possible. It took a lot of preparation from all of them. The good news for your fellow PhD students is that this protocol is now available also from them for all of them next week, with full support of the digital PhD from our university. But in the midst of all your concern for your son and girlfriend and the coronavirus for all of us, I still would like to take a little time to look back at your journey that brought you to this place at this very moment, finalizing your PhD. I have to go back to the summer of 2013 when we first met, I think during the annual ISCOM student meeting in June. You were already planning to come to Groningen, but really wanted to start a PhD project. You contacted me and Professor Harmsen to spread your chances to get something, and we spoke both with you. You had an interesting background and a CV for both of us. You come from the northeastern part of Iran, from Mashhad, a very historical city at the ancient Silk Road in the east, to the east. You started studying biological sciences in Iran, but soon moved to India, to the University of New Delhi, to continue with a bachelor and a master in biomedical sciences. After that, you moved to Spain to work as a research assistant at the University of Barcelona. Part of your work was related to liver disease, so I felt a good connection there. Unfortunately, at that time, I did not have a PhD position available, nor did Professor Harmsen. But you were willing to do everything to make it possible. And you were able to get financial support from your family for 2 years. This was such a good sign. Graduate school provided also an additional year of funding, so we could start a 3-year PhD project in November 2013. Marco and I decided to team up for the first time in supervising a PhD, and a project we entitled A Comparative Analysis in the Liver and the Heart, of analysis of fibrosis in the liver and the heart. Liver being my interest, of course, Marco for the heart, and fibrosis for both of us. Marco was, and I guess now even more, very much interested in the therapeutic application of mesenchymal cells from fat tissue, and exosomes were becoming very popular as carriers of the therapeutic factors. So you started to isolate these exosomes from ASCs, as we call them, and characterize them together with Patrick van Rijn. Soon you obtained very interesting results that these exosomes indeed seem to suppress the fibrotic phenotype of in vitro cultured fibroblasts. The next step was to see whether these exosomes also suppress liver fibrosis in mouse models in vivo. We were very lucky that we could collaborate with the group of Professor Kantbij and Essen, especially Svenja Tidor and Lars Begma, who have a lot of expertise in such experiments. You actually received 2 EASL fellowships for this collaboration, which is a very prestigious European grant for young scientists. Unfortunately, Lars cannot join today, but the fact that Professor Kantbij is one of your promoters and Svenja is your paranymph says enough, I think. It became a very fruitful collaboration. I really want to thank them for also here for their continued support for you and our collaboration. They made it challenging, though, the Essen group, because right in the middle of these mouse experiments, Professor Kantbij became departmental head at the University of Magdeburg. The whole lab moved from Essen to Magdeburg and needed to be built up again, including licenses for animal experiments. But Svenja managed everything very well, and we were able to perform all the planned experiments. Good thing was that we got to travel to Magdeburg once in a while, and I have great memories of our visit to the nice Christmas markets in Magdeburg in December. Travel for you, Daniel, was not always that smooth, because once I received a WhatsApp message from you at 1 o'clock at night that you were stuck actually in Nijmegen on your way home. I do not know how you managed, but luckily the next day you arrived safely back in Groningen. So what about Daniel outside lab stuff? I know you like biking a lot. I guess you have seen more of the local bike roads than I have. But you do this sometimes at very weird moments. Once you were scheduled for an early morning presentation for Marco's group and you never showed up. We were getting upset, of course, but then it appeared that you had decided to go for an even earlier morning bike ride first and made a terrible crash. Luckily, you did recover well from this, but I do think that there is some room for better planning in these cases. I could continue much more and tell about how Marco and I performed sometimes as good guy, bad guy in our bi-weekly meetings, or about stress levels you went through at various moments. But I'm afraid that this online laudatio is also limited to 6 minutes, and probably I'm already over time. So I want to finish by congratulating you, Hannah and Oscar, but also your family and friends for obtaining your PhD today. And I truly hope that Oscar will be healthy soon and you can start as a postdoc in the lab of Professor Kantbij, who, by the way, just moved to Bochum as departmental head. So this is much closer for us, so we look forward to continue our collaboration and publish the work of your PhD project. It is a pity that we cannot go to the Drie Gezusters as planned to celebrate your PhD now, but I hope that many of the people who are now online will also join in our Zoom party starting at 11. So now I would like to continue with the official promotion. And normally I would say stand up, but you are already standing up. So I will put my cap on and hope that many of the promoters and opponents can also do this. So if we are ready, then I would like to say that by virtue of the powers vested in us by Dutch law, in accordance with the decision of the College of Deans of this university, I, Klaas Nico Faber, confer on you, Danial Afsharzadeh, the title of doctor and all the rights associated with Dutch law or custom with a PhD degree at the University of Groningen. Do you, as doctor, promise to act in accordance with the Netherlands Code of Conduct for Scientific Practice?
I promise.
Very good. Thank you very much. Now that I have performed the task assigned to me, I can be the first, and I would like to hug you, but we do it online, to be the first to congratulate you with your PhD degree and to address you as the first one ever as Dr. Danial. Congratulations.
Thank you very much.
Very learned sir. As proof of this PhD degree, I will present you with the certificate which has been signed by the Rector Magnificus, the Secretary, and your supervisors, and which is sealed with the Great Seal of the University of Groningen. I'm also happy to present you with a small booklet as remembrance of this special ceremony, also as a remembrance of the University of Groningen and the city of Groningen, of course. In this booklet you will find no congratulations, but we have something to replace it, and that's this very special envelope in gold, where you will find all congratulations of the members of the opposition committee. Finally, I wish you and your family a healthy and happy future. However, before handing over the certificate and booklet, very learned sir, it is my pleasant duty to congratulate you in this special way, also on behalf of the Committee of Deans of the University on the degree you have been awarded. My congratulations.
Thank you.
And then I will hand over very special things, of course. I will just open it for you so you can see, and perhaps the camera can see it also. So this is certificate, and you will have it in Latin and in English. And there is also a small certificate that can be used abroad. Yes. So I hope you will enjoy it. Mostly I give it to the paranims, but now I cannot do that. I'm sorry for you. And then the small booklet from the University of Groningen. I will sign it because I did forget it. That I can do. Please. And then, perhaps most important, this envelope.
Thank you very much.
Okay. After thanking Mr. Gankema for the IT support, I now declare this meeting for closed.
Hartstikke.